problem we run into when dealing with solving equations is when the variable we're trying to solve for is in the exponent, we have to have some method of madness of being able to get it out of the exponent, because being in the exponent, we cannot solve the problem when it's in the exponent. So that's where the properties of logarithms will help us out. Probably the most useful property of logarithms, dealing with how we can eliminate an exponent and bring it down into things that are in operations of addition, subtraction, multiplication, division. So we could take the log, and it does not matter which log you take of both sides. But we could take the log, once again, I usually opt for natural log, because natural log is easier for me to write. I'm lazy. And using our properties of logarithms, when we have an exponent to a base, we can bring the exponent out front. So we have x plus 1, ln of 7 is equal to ln of e. Well, if we look at the right-hand side, the natural log is log base e of e. When you have log base e of e, or the ln of e, this is equal to a value of 1. When these two values are the same, we get 1. So what we're left with is x plus 1, ln of 7 is equal to 1. Now there's different ways you can look to solve this. One would be, I have multiplication by ln of 7. I could divide both sides by ln of 7. So we have x plus 1 is equal to 1 over ln of 7. And then we can subtract 1, subtract 1. And now we can clickety clack through our calculator, 1 over ln of 7 minus 1. If you wanted to, you could distribute over both your terms, which will give us x times the ln of 7 plus the value of one times ln of 7, and that's equal to a value of 1 still. We can subtract our ln of 7 and divide by ln of 7. So we have 1 minus ln of 7 divided by 7. Both of them should give you the same solution. Negative 0.486. Other questions, other problems on the front? Number 9, we have log base 2 of x. Plus log base 2 of x plus 2 is equal to a value of 3. Using our properties of logarithms on the left-hand side, I have two log base 2's that are being added together. I can combine them into one log base 2, but what do I have to do with the x and the x plus 2 then? Using our properties of logs. Okay, I can write this as one log on the left-hand side. What do we have to do with the x and the x plus 2, Jade? If I'm adding these two logs. Okay, we have to multiply them. So we have x times x plus 2 is equal to a value of 3. Next, we take it out of the exponential form, out of the logarithmic form and move it into an exponential form. So rewrite this as an exponential form now. Take it out of the log form, and write it as an exponential form. Rachel, what do you have? Okay. We have a base, we have our exponent, and we have our value. So we have base, exponent, value. So we have 2 to the third is equal to x squared plus 2x, or 8 is equal to x squared plus 2x. Solving this quadratic, we can subtract 8 from both sides. So we have 0 is equal to x squared plus 2x minus 8. Looking to factor that down. I have x plus 4x minus 2. So x equals negative 4 and 2. But then we have to take a look. Do we make any of our logs negative with either of these values? If I put negative 4 in here, I get log of a negative. And here it's be a log of a negative, so this we have to cancel out. If I put 2 in here, I'm good with log of 2 and log of 4. So I'm good with that. So my only solution would be x equals 2. Other questions on the front? All right, taking a look at backside, properties of logarithms. Anything you need me to go through on the back? Yeah. Number 14. Number 14. I'm giving you the ln of x is equal to 5, ln of y is equal to 7, ln of z is equal to 2. And we have in number 14 the ln of cube root of x over y squared. The ln of two things being divided. So I want to write these as two separate logarithms, natural logs. If I'm dividing, Sarah, what mathematical operation we're going to do if we have division? Subtraction. So we have the ln of cube root of x minus the ln of y squared. Now we have to take a look at the cube root of x. How can we write the cube root of x exponentially? Cube root of x exponentially. Justin?
1/3.
1/3. This is x to the 1/3 power. Both your exponents can get thrown out front of your natural logs. So we have 1/3 ln of x minus 2 ln of y. Both these exponents, once again, can go out front. The ln of x is 5. So we have 1/3 times the value of 5 minus 2 times ln of y to the value of 7. Now, and this tends to be a confusing part to students at times. When we have the ln of y there, they like to make that minus 2 times the ln of 7. They just put 7 in for y, and 1/3 times the ln of 5, which is incorrect. This ln of x is given to us as a value of 5. This ln of y is given to us as a value of 7. So we have 5/3 here minus 14. This is 1 1/3. So we have 5/3 minus 14, or 1 1/3, so that's 13, negative 12, and 2/3. And if you have negative 38/3, that would be fine too. I guess it is. I guess I was incorrect in the problem. Oh, 5/3 is 1 2/3, isn't it? My bad. There we go. That's a little better. I failed 5th grade math when I was making my mixed numbers. I couldn't do that wrong. Other questions on the back? On number 12, go ahead. Number 11. Number 11, we have ln of x squared y cubed over z. We have multiplication on top, and then we're dividing by z. So using our properties of logs, this will give us ln of x squared plus the ln of y cubed, because we're multiplying them. And then we're dividing by z. So we have minus ln of z because we're dividing by that. Exponents once again come out front. Ln of x, we were at a value of 5. Ln of y was a value of 7. Ln of z was 2. So putting in 5, 7, and 2. We have 10 plus 21 minus 2. So we have 41 minus 2, or 31 minus 2, which is 29. And problem number 12, we have to watch. We have the ln of square root of x times y, which is ln of x times y to the 1/2 power. So I can throw the 1/2 power out front. But I need to make sure when I separate ln of x and y by addition, I still maintain this multiplication. So we have 1/2 times the quantity of ln of x plus ln of y. Another way of thinking about this, you can write that as ln of x times the ln of y. I'm sorry, square root of x times square root of y. So we have ln square root of x plus ln square root of y. So we have 1/2 ln of x plus 1/2 ln of y. And we get the exact same thing we get over here. Other questions? Yeah, this is the last of the new material for chapter 4. I said it's a fairly quick chapter over logarithms. I have a worksheet today. The review sheet tomorrow will look very similar to this. Chapter tests on Thursday and probably part of Friday also, if we need to. Will look very similar to this also. Solutions have been provided for you. I also print some solutions, and the rest of the time is yours.